Evan, you can say hi to that thing. Yell loud, though, because it's my voice mostly. Say hi. Hi. Okay, now we're good. It's right here. It's capturing on the screen. All right. Okay, we'll get you to the geometry advanced level. Yeah. All right, here we go. Are you guys ready for the next no notes? Yeah. So did you guys notice what geometry is so far? It almost feels like a vocab class. Yeah, it's good. It's a good stuff. Well, today we're going to take everything that you've already kind of learned and we're going to take it to the good level so you really understand why. And we're going to use correct notation and we get to throw some algebra in for fun. Yes. Okay? So, I think algebra is fun. So, yes, we're throwing it in for fun. All right, so a few things you need to remember, some terminology. When we talk about a coordinate, it just means we're giving a number to a location, okay? We're giving a number to a location so we know where it's located. So guess what you've used for a long time in math? You guys remember the good old-fashioned number line, especially in pre-algebra, when you learned your negative numbers? Yep. Okay, it's a line. And all someone did on that line was divide it into equal spaces so I could put a 0 down and I could put positive numbers down. So when I sit there and say, oh, look, there's point A, you tell me it's at what? Okay, now take it three-dimensional. Oh, look, I have two number lines intersecting. Isn't that called a coordinate plane? So don't we do the same thing? We then have a grid, so we have the horizontal and vertical then. That's why we call them coordinates. It's so we can find them. We can locate things. I can put an arbitrary number there and I can start finding the length of things. Oh, look what the next thing is. It's called the ruler postulate. What do you do with rulers? Who decided where those marks go on the ruler? Someone else before us, right? But they did that so we arbitrarily know how long something is. We can measure it and stuff. All right, so let's write what the ruler postulate is. All right, the point on a line can be put into a one-to-one correspondence with, I'm going to go like that, real numbers. Basically, we're going to give real numbers to it so we can find measurements. Now, let's talk about this a little bit. We're talking about the distance between any 2 points. Do you remember how you first started figuring out how far things apart were on a number line? Do you remember it was like the hop approach? Or like the count approach, you go 1, 2, 3. If I want to know the distance between A and B, you would just arrow it over and count. All right, and then you realize that's kind of boring and you could be faster. Well, here's my question for you. If I arrow from the left to the right or the right to the left, did my distance change? No. It's still 3 apart, right? So that means distance always has to be what? Positive. Positive. So think about this. Anyone ever seen Ferris Bueller? Yeah. Okay. Do you remember the end of the movie when Ferris Bueller is the dumbest person alive? When he thinks that he can change the odometer on the car, and he sits there and they jack up the back of the car because it's a rear-wheel drive car, and they put the piece of cement and log it, and they put the car in reverse thinking the mileage is going to go off. What did Ferris forget? Distance is always what? Yeah, you never go a -3 miles home. For some of you, it's a -3 blocks home. But, or for some people in this room, -100 meters. But anyway, like you never go negative. You only ever go positive distance. And so that's why you can always calculate it. So let's write the definition down for it, all right? Because you've always known what distance is, but you've never defined it, right? All right, so the distance between any 2 points is the absolute value of the difference. Difference means what? Subtraction of the coordinates, which means distance is always positive. Think Ferris Bueller. Excellent. So, the distance here between A and B is also called the length, all right? Because what do we do on a line? Can we take a part of the line out and call it a line segment? So distance, the other word for it is length, okay? So I'm looking for the length of line segment AB. How many of you want to write out the length of line segment AB every time that you want to solve for it? Do you? No. So good, there's a shorter way. Correct notation. Let's see if I can get this to work for me. Come on, work. Oh, didn't go with the highlighter like I wanted. You just write a line segment, like you're naming a line or a line segment. And guess what you don't include? You don't include the bar over the top. You put the two endpoints right next to each other. The moment you don't include a bar, you're talking about it, and it literally reads, this little highlighted segment literally reads the length of segment AB. It takes away all that other writing that you see in that red box. So when you have an equal sign, so let me go with it this way. And we're going to put it for green. Never, ever do this. Oops. Oh, I did this again. Oh, you know what I did? I forgot to put it in tablet mode. Here we go. Tablet mode. All right. Never, ever do this. You know what you just told me? You're saying line segment AB is 3. Does that make sense? No. By the way, if you do that, I take a full point off because your answer is wrong. The correct way of saying that would be the length of line segment is 3. That's the difference between saying Mrs. G or Mrs. G's weight. One's a descriptor, one's just my name, right? One like you say, oh, I have Mrs. G. You identified me. But if you say Mrs. G's weight is, now you're describing something about me, and no, you don't get to find out my weight. I know, bad humor. Sorry, guys. Some of you actually laughed today. We're moving and improving in this class. This is good. This is good. So how would you actually show the work? Because guess what? Do I want you to show the work? Yeah. Make sure you use an absolute value sign, and you just take the difference of the coordinates. I don't care which one's first. We just know the absolute value is going to get you there. Right? So let me show you what I want to see on your homework. Oh, look at diagram A. A number line. Oh, okay. Nothing different in your life. Number lines still show up all the time. It says, what is the coordinate of point C? What did you guys get for the coordinate of point C? So that's pretty simple. Moving on. Now, how does this read in example 2? It says what? Find, the length of segment BC. So when I'm doing that, the moment I have an equal sign, the bar can't go on with it. But can't I just quickly do that? Well, what are my coordinates for B and C? Yeah, -4 and 2. So can I go -4 minus 2? And that gives me a -6. Well, what's the absolute value of -6? 6, bless you. All right. Now, could I go 2 minus a -4? No. That still gives me 6, the absolute value of that. So remember, it can go the other way. So how would I do the length of segment EC? Can I go, I like going the negative first. I don't know why. -3.5 minus 2. Isn't that going to be 5.5? Yeah. So the length of segment EC is 5.5. But remember, this will get the same thing accomplished. Do I want to see that work, even though it's easy? Yeah, I need to know your thoughts. Otherwise, you're just copying from the person next to you. Remember, God does not give me the gifted ability to read your brain cells, people. I can only do it if you show me your work. Plus, you got to do it for your other classes, so I'm going to train you how to do it well. All right, so let's keep going with this one. We talked about congruent segments. Guys, you know what the word congruent means. What does congruent mean?
The same.
The same shape and the same what? Size. Same shape and same size. So if I have congruent line segments, we know that they're just line segments that have the same length. So a simple illustration of that in the diagram, just draw 2 line segments that are the same, label their endpoints, pick letters you like. Geometry teachers aren't original. We normally go A, B, C, D. If they're exactly the same length, that means they have to measure exactly the same. So I'm going to say they're both 5. But if that's the case, we have to use notation that says they're the same shape and they're the same size. So this time you'd go segment AB. Notice, what did I put back on? The line segment bar came back on, is congruent to segment CD. So we put notice it's an equal sign with one top of it, like a little squiggly line. It's tilde if you're in Spanish. It's the similarity symbol is what it is, that if you had similarity before. So that when you read that, that goes segment AB is congruent to segment CD. The moment you know they're same shape, same size, you can go ahead and assume an equal sign. You automatically know that's true. Then I can do all the math I want with it. So down below, in the diagram below, it says right here, the length of segment PQ is equal to the length of segment RS. Notice, I can write it then, because the moment I know they're same in length, and I know they're line segments, they're congruent. This allows you to go between the two. If I ask you for congruency, you put a congruency symbol, you put a bar in it. If I ask for length, you take the bars off, you have an equal sign. You have to be able to fluctuate between the two. Does that make sense?
Yes.
All right. You also need to be able to learn in this class to mark up your diagrams. It pays off on standardized tests, and it pays off on my tests and quizzes. So always mark diagrams. So we use really fancy things. They're called tick marks. They're little slashes on there. And if they have the same slash, you know they're the same length. Because let me tell you right now, most things in geometry are not drawn to scale. You have to go by the markings or what I tell you about them. Because they want to know if you know the rule or not. So you want to use the same tick marks. Does that make sense? All right, some other terminology we need to know. It says, in order for you to say that point B is between something, 2 points A and C. So let's get 2 points A and C. Here's A and here's C. Do you guys agree with me on that so far? Because any 2 points determine a what? A line. One of your postulates yesterday, correct? So we know any 2 points determine a line. When would B, the point B, be between those two? Where does it have to be? In the middle. Does it have to be smack dab in the middle? No. It just has to be like somewhere over here, or if I didn't like it there, oops, erased everything when I did that. Could I put it over here? We just know it's somewhere. It's almost like a bead that slides on a stick, right? It's somewhere in there. But they have to be on the same what? They have to be on the same line. So in order for that to happen, all 3 points must be on the same line. So basically, if something's on the same line, it's called what? I think yesterday. Points on the same line? Collinear. Exactly. And as a result, could I pull off and destroy my arrows at the end there? Could I make line segments? And could I then say segment AB and segment BC add together to get the bigger one? Welcome to your next postulate. It's called, get this, segment addition postulate. Because what am I adding? Basically, I'm putting them together. All right, so let's write this down. This is, again, postulates aren't provable. They're just what? True facts. So to me, this is like, postulates are the common sense things that we all know, right? So let's write it down. If point B is between, oops, between has 2 E's. All right, between points A and C, then the length of segment AB plus the length of segment BC equals the length of segment AC. And a lot of you would think very common sense stuff like this. Let's say this was 3 and that one was 5. What's the length of segment AC? You just add them together, right? So how about if we had a phrase instead of this whole long formal thing to memorize? Wouldn't it be nice if we just had a quick phrase? All right, I have one for you, and you can use it. And if I say, all right, what is the basic idea of segment addition postulate? You could actually say this for me. How about the following? Sum of the parts equal the whole. Does that make sense? Could I have more than 2 segments that add together to be a bigger segment?
Yes.
Yeah. So that's why it's almost a fail-safe way to say sum of the parts equal the whole. All right, so few things you need to learn about geometry. If you're a slightly visual person, this class is for you. Okay, you're gonna like it. But the problem is sometimes they don't give you the visual. What do you have to do? Make it. So you're gonna get really good at drawing stuff and reading things well, okay? And the other thing that I yell at you for is like, did you draw a diagram? Did you mark it up? Did you put your given information? I'll just start asking you, did you do everything you're supposed to before you ask the question? Okay, so on this first one, let's just start very easy because it really is. All right, it says point G is between F and H. Do you see a diagram there? No, but I know here's F, here's H, and I'm going to put G somewhere between them. Then I have the rest of my given information. They say the length of segment FG is 6. The length of segment FH is 11. Notice that I can't really put it right with the G, but does that give us a good idea what it's like? So then what's my question asking? It's saying find the length of segment GH. Well, guys, how would you find the length of segment GH? Yeah, just take the whole minus the part, right? All right, there's your work. There's your answer. Woo. But give yourself the visual. Doesn't that become really easy with the visual? All right, look at the next one. It's example 5. Point M is between N and O. Oh, look, I was nice this time. I gave you a diagram. It says find the length of segment NO. So I want the big segment. Okay, so there has to be some way that I can find the length of the whole thing. Suggestions, anyone? Tavis. Yes.
So for the last one, we have to put GH equals 1.
You want to, because isn't that what you're looking for?
Yeah.
All right, and if you just said to me GH equals 5, I wouldn't believe that you actually did the problem. You could get it from someone else. I need to see that you actually did the math too. Okay, it takes 10 seconds, not even 10 seconds, probably a second for most of you. Just get used to always, what I really want you to do is learning to justify everything you're doing for me. I want you to come up to me and say, look what I did. You can't argue with me, okay? Because guess what? Tavis, sometimes you're going to do it different than me and you're still right. And I want to give you the full point for it, the full credit. All right, so what do you guys think about this one? What do I do?
17 plus 3x minus 5 equals 5x plus 2.
Yeah, guys, can I use the sum of the parts equal the whole? Look at that smiley face. Isn't that cute? All right, anyway, so let's go here. 17 plus 3x minus 5 is equal to 5x plus 2. Oh, look, what friendly thing came into your life all of a sudden? Algebra. All right, so let's always simplify first before you start moving sides. So then we end up moving the 2 over. I'm going to go 3x plus 10 is equal to 5x. What do we got here? 10 is equal to 2x. X is equal to 5. Are you guys good with that? Or 5 is equal to x. Is that the same thing? All right. No. What did I do wrong?
You have to do NO, that's just x.
Thank you, because I wasn't done with the problem, but you're totally correct. You stole my thunder. It's okay. You can steal my thunder when it's good like that. All right. What were you telling me? Explain to me again. What was wrong?
That's x. It's not NO.
Did I actually? Yeah, I never finished the problem yet. I found a variable, but did it find the actual length I wanted? No, I don't have the length. So guess what? We got to finish it. So always reread your question, right? And then all you have to do a lot of times is plug it in, right? So let's plug it in. So we got 5 times 5 plus 2. What do we get? 27. All right, just off the cuff, what's the length of segment MO? Can you just go 27 minus 17 to get 10? Notice I didn't have to plug it in. You could plug it in, but you don't have to. All right, let's keep on going. We got more to do. Midpoint, guys, where's midpoint? In the middle of a what? Line segment. Thank you. Now you know what a midpoint. Now, there's going to be a few more things you need to know. It does special things. So if you have a midpoint, remember, it is a point that divides a line segment into, and this is where it's huge for me, into 2 congruent segments. You all know what a midpoint is, but I want the result of it. I want 2 congruent segments. So when I give this to you, and I show you line segment A, B, if M's the midpoint, what should I mark on there? Yeah, 2 tick marks. One there, one there. The moment you see that, what do you know about those 2 line segments? So anytime you're given a midpoint, you always automatically do that. All right, yes, sir. Ask your question.
So for example number 5, that one that we just did, what if it was like, so instead of 17, it was like 1x plus 1?
Do the same thing though, right?
But what would how would you get the answer?
You would still have an equation you could set up. You'd have to solve it without variables then. So it would still work. In fact, we're going to go some examples more later. All right, so let me talk about notation. This is what you would do. If M is the midpoint, and I abbreviate midpoint, by the way, guys, just let you know that, of segment AB, what do you automatically know? What did my tick marks just tell me? They're the same. Segment AM is going to be congruent to segment MB. If I give you a midpoint, you always mark 2 congruent segments. Are you guys with me on that? So let's apply it. Let's have a little bit of fun. Some easy, some a little bit harder. All right, example 6 here. It says H is the midpoint of IJ. What's missing again? A diagram. Make sure you give it to me. Here's IJ. H is the midpoint. What should I mark on there? If it's a midpoint, you should automatically mark 2 congruent segments. If not, you'll get yelled at, okay? Always give me 2 congruent segments. And then length of segment IJ is 9.4. So I marked everything I knew on that diagram. But look what I'm asking for. I want the length of segment IH. Guys, don't make this a hard problem. What would you do? Thank you. Can I just get 4.7 and be happy about it? Great. Was that a lot of work I had to show? Nope. Don't complicate it. Sometimes it's meant to be that easy, okay? It's supposed to be that easy. Some of you are like, well, I had to do that on the calculator. You still got to show me what you did before you put it on the calculator, okay? All right, next one. It says D is the midpoint of segment EF. So we know D. Do I put my 2 tick marks right away since it's a midpoint? Yep. And then I mark everything I know on the diagram. It says the length, because remember, no bar means length, right? The length of segment ED is 4x plus 6. The length of segment DF is 7x minus 9. Find the length of segment ED, DF, and EF. Can I use the segment addition postulate this time? Can I use some of the parts equal the whole? Do you know the whole? Do I know the whole? No. But I know the parts, and what's so special about those 2 parts? So can I, now they don't equal the whole, they add together whole. I agree with you, but how am I going to solve so I can figure out their lengths? Yes. Yeah, put them equal to each other. Because what do we know about them? They're congruent. So I know if they're congruent that I can sit there and say, oh, I know that they're both equal. I know their lengths are going to be the same. So when I do that, I get 3x is going to be equal to 15. Did you guys get x is equal to 5? Again, am I done with the problem just because I got a variable? No, I have to plug it what? Back in. How many times do I actually have to plug it back in? Not meant to be too much of a trick question, but think about it for a moment. Let's go there. I'm still a mathematician. I don't want to do very much work if I can help it. Do you guys agree with me that ED is 26? What's DF? I don't have to plug it in again because I already know they're congruent. All right, what do I know about EF? What's the whole? Notice I'm not plugging back in. No way. If I can just double it, go for it. Okay? Just don't put a bar with the equal sign. We're going to be good. All right? Try the next one. Suppose that T is the midpoint of segment XZ. Well, I'm going to suppose that then. Here's X, here's Z, here's T. What do I got here? 2 congruent segments. So what do I get here? 2x plus 11. And I get 5x plus 8. Oops, excuse me, xz. Make sure I get the right one. Sorry about that, guys. 5x plus 8. I want to find, this time I do want the variable. How am I going to get there? Jason. But I do have the whole. I have 5x plus 8. What do we think? What do we think? What do you think? Peter?
Do the 2 segments added together equal.
All right, so you're saying I got to use xt plus tz is equal to xz. Okay, I know what xt is. Do I know what tz is?
Yes.
It's the same thing. Yes, that also works. Is it doing the same thing? I'm just trying to use the segment addition postulate so you see it. But if you go 2 times the quantity 2x plus 11, is that the same mathematical fact? Yep, so you can do it either way. So I get 4x plus 22 is equal to 5x plus 8. I get the fact that x is going to be 14. What did you guys get? What do you guys think? Easy schmeezy?
Yeah.
We're almost done. All right. Have you ever taken that many notes yet in math before?
Yeah.
Probably not as much writing, a lot more problems. It's fast. And guess what? You've kept up. See, you're smart people. All right. I'm going to spoil you. If a teacher ever talks slow after this, you're going to be like, oh, this is so rough. All right, next one, segment bisector. What does a bisector do, guys? Divides it in two. Okay, we're in geometry. It's going to divide it perfectly in two. So it's going to give me two congruent things when I do that. So if I have a segment bisector, it's going to be a ray, a segment, or a line that intersects. Oh, that looks horrible. I got to rewrite that word. A line segment at its midpoint. Basically, wouldn't it do the same thing as a midpoint does? It's going to divide it into two congruent segments. So here's what I mean. You're going to see something like this. It'll say something like, if line L bisects segment AB, then I know, and let me draw this out so you can see the picture over here. So here's AB. Make some pretty line go through the middle of it. So we're going to go line L. It has to go through what point? The midpoint. We know this is the case. So if it's a segment bisector, then I still have two congruent segments. All right, so I know segment AM is congruent to segment MB. Isn't that really just what a midpoint does? So what we do instead, we try to confuse you. We'll say, oh, line T bisects line, segment, BD. And you're like, oh, I just treat it like a midpoint. Does that make sense? All right, yes, sir.
What happens if line L doesn't bisects it?
Then it will just be like a segment addition problem then. So then be like two parts equal the whole. It wouldn't be able to divide it perfectly. Okay. So good one. All right, let's do this last problem here then. We'll be good. It says hint, mark up your diagram. Guess what your hint for your homework is? Redraw the diagram, mark it up. You'll be great. So it says the following. Segment LH bisects segment GK, which means I get two congruent segments. Does that mean GK bisects LH? No, it's just going one way. Be careful not to flip that around. It has to say bisects each other for it to be that way. And then let's just mark what we know. We know the length of segment GM is 2x plus 6, and the length of segment GK is 24. Doesn't that look really familiar? Because look what it says. I just want you to solve for x. Suggestions, anyone? What do we got here? It's the same. If they're congruent, if I know the length of one, do I know the length of the other? Yeah. Now, for those of you who wanted to go fast, is this the same thing as before? I just put a 2 in front of it in one expression. Is that good? All right, let me finish writing this down. You guys are free to go. Don't forget to do the online quiz. That's the last 3 questions for the syllabus, okay? See you guys. Have a great weekend. Stay safe and out of trouble, scholars.
So should we put all of our notes in our binder?
I always would put your notes in your binder. Every